Hello, welcome back to my channel on physics course. I'm gonna to show you something regarding the problem solving in Cambridge International S level and A level for Cambridge Assessment International Education. Yes, the subject is physics. Paper 2 S level structured questions. This is 9702 slash 202. We have 1 hour 15 minutes here. But before you see video, please subscribe on my channel. This uh, my channel is physics course. Yeah, and my name is Widodo from Indonesia. Okay, let me start to continue uh, next page. Yes. Oh yeah, this is me. If you want to see me, yeah. Okay. Number one, the speed v transfer wave on uniform string is given by the expression v root of TL divided by m, where T is tension in the string, L is length, and M is its mesh. I want to close my picture first. Okay. An experiment performed determined the speed v of the wave. The measurements are shown in table 1.1. Quantity T, L, and M. T 1.8 Newton with uncertainty around 5%, and L is 126 centimeter with uncertainty plus minus 1%, and mass is 1.5 gram and 32%. The question A is use the data in table 1.1 to calculate the speed. Okay, we have this formula, and so we calculate about the V. V it's mean, yes, V equals root of T times with L. So if we directly use the number 1.8 times 0 point uh, this is in meter 1.256, sorry, uh, and divided with mass is 5.1, but we need to change into kilograms, so this is times with 0.001. So actually we get after we calculate unit calculator, uh, yeah, here is, yeah, calculator is around 21 meter per second. So the answer is here 21 meter per second. Okay, continue the next question. Use the answer if in A, in the data table 1.1 to calculate the absolute uncertainty in the value of V. Yes, we have percentage uncertainty. It's around 4%, right? It's been 4% by a velocity, so we get this is around 0.04, yeah, times with 21. It's around 0.8 meter per second. So finally we get the answer is 0.8 meter per second. Okay, Continue the next question. Define the acceleration. Acceleration actually rate of change velocity. This is about rate of change velocity, or this is about other answer is change in velocity with over ch, ch in velocity divided by time taken. Yes, that's the definition of acceleration. So, question B: a ball is kicked from horizontal ground toward a vertical wall, as shown in figure 2.1. Yeah, this is the ball with inclined angle is elevated angle is 28 degree. Uh, this is path of ball until the wall. This is horizontal growth, and the length of the start from the ball projected until the wall is 24 meter. Yes, okay, we see on the above explanation. The horizontal distance between the initial position of the ball and base of the wall is 24 meters. The ball is kicked with initial velocity v at angle of 28 degrees to the horizontal. The ball hits the top of the wall after time 1.5 seconds, and air resistance is negligible. Yeah. The question I is calculate the initial horizontal component Vx of the velocity of ball. Vx is this is around because in the x, sorry, this is wrong. Because in the x there is no acceleration, then like distance equals to the same thing with distance, yeah, equals to velocity times time. Yeah, so if we want to get the velocity fx, this is fx around distance divided by time is 1.5, so we get velocity is around 16 meter per second. Yes, this the answer for this question about velocity on the x direction. There's around sorry 16 meter per second. Okay, continue the question II. So the initial velocity component Vy of the velocity of the ball is 8.5 meter per second minus 1. Okay, Pi, if we know about the tangent, yes, tangent tangent 28 degree, it's mean Vy divided by Vx. Yeah, so Vx is V cos 28. Vx is V cos 28, and Vy is equals to V sine 28. So, uh, if we continue to how to find this is about a Vy is we know what V is 6 here. Okay, V is 10, 28. Yes, correct. Because we already get the V is 16. Yeah, yeah. Okay. This is Vx. Yeah, because tangent 28 degree equals to Vy divided by Vx. So we get the, yes, correct. Vy equals to, as the mentioned before, 2.8 meter per second. Yes, this is the answer of II. So, question III. Calculate time taken for the ball to reach a maximum height above the ground. The maximum we can use the equation that V in every time equals to VO, or initial velocity, plus AT. Yeah. So we get T equals of, because uh, we need the time until the ball reach on the height above. Yeah. So we use V as 8.5, as I get before, divided by A. This A is gravitational acceleration, it's mean 8.81. So we get T around, after we calculate, around 0.87 second. Yes, this is the answer of question III. That time is 0.87. Yes, here is 0.7 second. Okay, let's continue to question IV. The ball is kicked at the time t0. Assume that vertical component Vy of the velocity the ball is positive in the upward direction. On figure 2.2, sketch the version with time t of Vy from the time until the ball hits the wall. Okay, we got to strike length from Vy at t0. Yes, start from here. Uh, we will use line. Use line is here or here. Start from here. And for TO negative Vy T 1.5. 0 to 8. This is around to 8.5. Yes, 8.5 to, point. Yes, I think here at around 8.5, 8.5. Yes, around here, and here I think yes, on the 1.5. Sorry, see the 0.87, 0.87. Yes, maybe around there. Yes, we cannot to draw the line because it's so complicated. Yes, the graph around from students here until the maximum here, and then go back here. Okay, let's continue to the next number. Calculate the maximum height above the ground of the ball in P. We can use some equation. So, but if you use the, I think this, you can use this as equals to ut plus a half et square. Et, let's say this is square, yeah. Okay, this s equals to, if you know about u is u is 8.5, yeah, I think yes, u is 8.5 times, and the maximum is 0.87 plus a half of A is gravitational acceleration, but this is negative. Well, come to grow up. 9.81 times with T. This is 0.87 square. Yes, 0.87. I think this one. Yeah. And then if we calculate, this is equal speed. Yeah, around. Yes, times with 3.7. Yes, 3.7 meter. Yes, finally we get the answer is around 3.7 of the maximum height when ball is on the point maximum height. Yes, 3.7. Okay. Question II. Yeah. The maximum gravitational potential of the ball above ground is around 22 joules. Calculate the mass of ball. Okay, we know about the formula of potential energy is mgh here. The potential energy is mgh. So how to find m? M is equals to potential energy 22 divided by gh, 9.81 times with uh, H is 3.7. Okay. 3.7. So we get this calculator here. But 0.61. Yes, the answer is 0.61 kilograms. So we get the answer is 0.1 kilogram here. So the next question is D. A ball of greater mass of kit with the same velocity as the ball in B. Air resistance is still negligible. State and explain the effect, if any, of the increased mass of the time taken by the ball to reach its maximum height. Uh, Acceleration, yeah, acceleration of the free fall. Acceleration of the free fall um, is a charge, is um, is a change. Yeah. Never be changed. Yeah, never be changed. Why? Because the it's about the gravitational acceleration, or mm, not dependent on mass. And so no effect of the time taken, and so no effect. Oh, sorry. So not effect on the time taken. Yes, as this is the best fit answer. This acceleration if free fall is unchanged. Yeah, because this is only gravitational acceleration or not depend on mass. Yeah, and so the effect on the time taken. Okay, question number three. Define force here. Force is rate of change momentum. If you know this, yeah, change of momentum. Sorry, and also or change momentum divided by time taken. Yes, this is the best answer. Yeah, the define about force is rate of momentum, or this is change in momentum divided by time taken. Continue state what it's mean by work done. Yeah, by work done. Okay, work done is force displacement. Yeah, work done equals to force, yeah, times mm, displacement. Sorry, yeah, but in the same direction. Yeah, in same direction with force. Yeah. Yes, this is the best answer. Yeah, the best answer about the work done. Work done is force time displacement. Yeah, but the displacement is in the same direction. That force and displacement is same direction. Okay, now continue to B. We have feature 3.1. A block mass of 0.4 kilograms slides in straight line with constant speed 0.30 meter second minus 1 along a horizontal surface. As on figure 3.1, yeah. Block 0.4 kilogram with velocity 0.30 meter second minus 1, and then his spring. So assume that there are no resistive force opposing the motion of the block. The block hits the spring decelerate the speed of the maximum of the box zero when the compression and the spring 8 centimeter. Calculate the initial kinetic energy. Okay. Uh, Kinetic energy is over here. Kinetic energy equals a half mv. Let's say this is square, yeah. So this is equal of a half. Mass is 0.40 times with velocity is 0.30 square, not times 2, yeah, but this is square. So we get, if we calculate 0.2 times it, and then we get kinetic energy around 0.018, maybe one, yes, 0.018 joules. Yes, this is the answer of this question. Yeah, the kinetic energy is 0.018 joules. Then continue to II. The variation of the compression X of the spring with the force F applied to the spring is shown in figure 3.2. Yes, we have a force in X direction with F max. Sorry, X in centimeter 8, the maximum force here. Assume that elastic potential of the spring when the compression is 8.0 centimeter is equals to the initial kinetic energy of the block. Use the answer BI to calculate the maximum force exerted of spring of by block. Okay, we will use about the energy kinetic as the work done, so we get the kinetic energy means the area of this graph, a half f, sorry, f max time with x. Yeah, because this is a triangle, the area of triangle is a half f times with height is x. Yeah, okay. It's mean the kinetic energy before is 0.08, 0.018. This is equal of a half um, times with f, and then x is 8 centimeter. We change into meter, 0.08. So we get the f is f equals to 0.018 divided by 0.04, so we get f around 0.45 Newton. Okay, this is the answer for this question. Yeah, around f maximum, that's f maximum 0.45 Newton. Okay, calculate the maximum distortion of the block. How the maximum distortion of the block? Yeah, if we use the formula of Newton's second law, yeah, Newton's second law is F equals to ma. Sorry, okay, yeah, we have m is 0.45, so we get means 0.45 divided by mass is 0.40. Yes, uh, we get a around zero. It's around 0.1. Sorry, 1.1, around 1.1 meter per second square. This is square. Sorry. Yes, the answer is 1.1 meter per second square. Yes. Yes, this is the answer for this question by Newton's second law. So, continue to the next number. State and explain whether the block is in equilibrium. Okay. We have two questions here. Before it hits the spring, and when its speed becomes zero. Okay. It's about the constant velocity. Yes, constant velocity. Or why constant velocity? Because the resultant of force, yeah, is zero, correct. So in equilibrium, yes, this is what we call as the Newton first law. If there is no resistant force, if there is force is zero, it's mean as constant velocity of all on the rest. Yeah. And how about this translation? Is if resultant of force not a zero, yeah, not zero. So is not in equilibrium. Yes, this is the best fit answer. Yeah. We know about the Newton second law and Newton first law. If the constant velocity resultant force is zero, yeah, why become there is no acceleration. Yeah, so it's in equilibrium. But the solution resultant force not zero, it actually in negative force. Yeah, so not in equilibrium. Okay. Oh, sorry. This is the answer for the below one. Yeah. This is the answer below one. Here. Yes. This is the answer of below one. About the solution. Okay. We continue to the next number. Yeah. On V. The block is now replaced by another block of the same mass. Yeah. Frictional force effect the position of this block so that it has speed of 0.25 meter second minus 1 when it makes contact with the spring. A short time later, the block has speed of 0.15 meter second minus 1 as it lost contact with the spring and moved back along its original path. Calculate the magnitude of change in momentum of the block. It's so easy. It's about the momentum change here. So we get the uh, momentum change here. Change in momentum. Sorry. Yes. Delta P or change momentum is mass times with change in velocity. So, yes, it's mean change momentum. This is around of 0.4. Oh, this is the mass and change momentum. Yeah. Uh, this is around 0.25 mean negative of 0.25. Why mean and negative? Because this is going back and the direction of because opposite direction, so this is negative and this is minus here, so this is the answer is 0.2, sorry, 0.2 kilogram. Oh, sorry, this is 15. Sorry, this is 15. So we get this is around 0.16 Newton second. Yes, this is the answer for the this question. Yeah, about the change in momentum. Okay, we will continue later and in the different video. Thanks very much for your watching my video. Don't forget to subscribe. Yes, don't forget to subscribe. Uh, maybe like and comment. Thanks.